This is Satya Natarajan, AI transforming manufacturing from theory to the real world impact. Welcome to the podcast. Today, we have Ramesh Rakesh, Technical Director at Bosch, joining us from Bangalore. Ramesh is a visionary leader at the intersection of AI manufacturing and cybersecurity with deep expertise in digital transformation. He's published researcher with multiple patents and research awards. Ramesh, welcome.
Thank you for the kind introduction, Satya, and thank you for having me here. It's a great pleasure to be here and to be part of a conversation which is focused on how AI is shaping the future of manufacturing. So I'm looking forward to sharing my perspectives and in return, learning from the discussion, exchanging the ideas.
Thank you. Before we could take far to AI, I need to kind of pick upon your personal journey as well so that our viewers will know from where do you come and what sets apart. Your colleagues describe you as someone who bridges technology and business strategy seamlessly. What sparked your passion for AI and manufacturing, and how did you develop this unique blend of expertise?
Oh, that's a great question. So for me, the interest in this space really started quite early. I have always been fascinated by how complex system works, especially during my early careers when I was spending time in big manufacturing plants. I used to amaze how small blocks well optimized or well simulated, and these factories are built in acres. So every point, every step you are seeing huge amount of optimization, simulations, involvement of human force, involvement of tools, machines. So this has kept me fascinated, whether it's a machine on a shop floor or large-scale digital platforms, and how a small decision in design or data can have a big impact on outcomes. And that curiosity naturally pulled me towards engineering and later towards data, automation, and intelligence systems. So what struck me was that technology alone never solved problems. Success depended on how well it aligned with business objectives like productivity, quality, safety, cost, etc. And that realization became a key turning point for me as well in my career. So I started focusing not just on building advanced technology, but on understanding the why behind it. What problem are we really solving? And how does it create value at scale? Another important shift came when AI started moving from research into real industrial use. Manufacturing generates enormous amount of data, but unblocking its value requires trust, reliability, and security. And that's where my interest in cybersecurity and resilience system came in. In connected factories, AI without security can quickly become a risk rather than an advantage. So the intersection of AI manufacturing and security felt both necessary and inevitable. And over time, this blend of technology, depth, and business context shaped my approach. So I see AI not as a standalone innovation, but as an enabler, one that must be practical, secure, and deeply integrated into manufacturing processes. And that mindset had guided me in my work, my research, and how I think about digital transformation in industrial environments today.
Yeah, so I was kind of appreciating the fact that how your journey from curiosity to what's in it for the company and how resilient it could be. That's an amazing journey to hear from the person who has gone through that. Now shifting gears a little bit, I just wanted to understand the philosophy on the technology and the change that it brings in. And I happened to go through your tagline, which is change is the catalyst, growth is the outcome, and purpose is the constant. How does this philosophy shape how you approach technology transformation in manufacturing?
And this tagline is really close to my heart. This reflects how I think about transformation in manufacturing. See, change is the catalyst because manufacturing is constantly under pressure, whether it's cost, quality, sustainability, or resilience. Technology adoption usually starts when something has to change, not just because a new tool is available. And growth is the outcome, but I see growth in a broader sense. It's not only financial performance, it's operational maturity, workforce capability, and the ability to scale reliably. AI, for example, creates value only when it improves real outcomes on the shop floor, in planning, or in decision making, not when it remains POC. And purpose is the constant. Purpose answers the question, why are we doing this at all? In manufacturing, purpose could be improving safety, reducing waste, increasing energy efficiency, or enabling faster innovation. So when purpose is clear, technology choice become clearer too, and that's how you stop chasing trends and start solving meaningful problems. Basically, you are away from the herds. And this philosophy also helps balance ambition with execution. It's important to be ambitious with AI and digital transformation, but manufacturing environments demand pragmatism. You need solutions that are robust, that is secure and adaptable by people. So personally, I focus on small purposeful wins that build trust and then scale, rather than trying to transform everything at once. So in that sense, the tagline is both a mindset and a practical guide for navigating complex technology change in industrial environments.
I think you nailed it, saying that the means to an end should always be about balancing what the technology has to offer and what gets executed. Well said, well said. Now we go on to just analyzing the larger AI manufacturing landscape. So in the light of it, I would like to talk about the broader manufacturing landscape, and AI is transforming how factories operate globally, not just locally. What's your perspective on where the industry is today?
This is a fantastic question. If you look at AI adoption in manufacturing globally, I would say the industry is at a transitional stage. We have clearly moved beyond experimentation, but we are not yet at widespread enterprise scale maturity. Most manufacturers today sit somewhere between pilots and selective production deployments. So adoption rates vary significantly by sector and demography. Discrete manufacturing sectors like automotive, electronics, and semiconductors tend to be more advanced, and now I can also add healthcare. So these industries tend to be more advanced, largely because they already had strong automation and data foundations. Process industries like chemicals, metals, or energy are also making progress, especially in areas like process optimization and predictive maintenance. Geographically, regions with strong data infrastructure and talent ecosystem, I'll say parts of Europe, North America, and East Asia are further along, while emerging markets are progressing quickly, but often in a more targeted use case driven manner. In terms of common use case, we see relatively strong adoption in areas where clear ROI and measurable outcomes are defined. And these include predictive maintenance, quality inspection, demand forecasting, energy optimization, and most important, AI-assisted decision support for planners and operations. So these are problems where data is available, impact is visible, and adoption barriers are manageable. That said, there is a noticeable gap between early adopters and laggards. I hope terms. So early adopters typically treat AI as part of a broader digital and business transformation. They invest in data platform, skill, governance, and change management. Laggards, on the other hand, often approach AI as a standalone technology, which leads to fragmented pilots that don't scale. So the biggest challenge today is not algorithm, it's integration. Integrating AI into legacy systems, workflows, and human decision making remain difficult. So while the technology is ready, organizational readiness is still catching up. So overall, I would say the industry is at a point where the focus is shifting from can AI work to how do we scale at responsibly and sustainably across the enterprise. And that's a very important transition. I hope answering your question.
Very true, very true. I mean, from the pilots to the scale and the advantages of the adopters, counting it as a technology to looking at it as a tool towards the laggards determines the maturity. And though the tool is well deployed and we know the possibilities of it, scaling it for a purpose comes out very naturally in this conversation. And that brings me to the use cases that you had described. Let's dive into some specific applications that are transforming manufacturing, because as we know, water everywhere, not a drop to drink. So predictive maintenance, we have heard enough. And I mean, any of the conferences you say around manufacturing, predictive maintenance is one of the most mature and impactful use cases. But though it looks like a no barrier for manufacturer, can you explain how it works and why adoption has been slower than expected?
That's a fantastic question again, Satya. And traditionally, manufacturers relied on reactive maintenance, where equipment is fixed after it fails, or preventive maintenance, where they'll say, I'll replace on a fixed schedule, whether they need it or not, right? Predictive maintenance sits in between. It uses data to anticipate failures before they happen and intervene only when necessary. So I wanted to set the context. Now, from a technology perspective, predictive maintenance basically depends on three key elements. First, reliable data, usually from sensors or which measure vibration, temperature, pressure, etc., acoustic sound. Second, data pipeline and context, so that raw signals coming from data are connected to asset operating conditions and maintenance records. And third, analytics or AI models that can detect anomalies, predict degradation, and estimate remaining useful life. We say it RUL, very quite common terms. Now, where the value comes from is not just avoiding breakdowns, but optimizing maintenance itself. And when done well, this predictive maintenance can reduce unplanned downtime. This can extend asset life, lower spare parts inventory, and improve safety. So in environments with high asset criticality or high downtime cost, the ROI can be very compelling. So why has adoption been slower than expected? One reason is complexity. Many factories have legacy equipment that was not designed to generate data, and retrofitting sensor and connectivity takes its time and investment. Right? The another challenge is data quality and scale. Models that work on one machine don't automatically generalize across fleets or plants. And then there is a third aspect, which I'll say more organizational, is change management aspect. Maintenance teams need to trust AI recommendation, and how that trust will come, that will take time to build, which again involve cost. Predictive insight must fit naturally into existing workflows. Otherwise, you will have to ignore, because ultimately the maintenance team is responsible for downtime. They are responsible for cost, and manufacturing areas is high cost intensive build, right? So predictive insights, if they are not sitting naturally into existing workflow, as a maintenance team, you will definitely ignore it. And finally, the business case, which is sometimes underestimated. Organizations focus on technology cost without fully accounting for the cost of downtime, production loss, or safety incidents. Because these are the easy things where you'll say, okay, we can manage this part. So in my view, successful predictive maintenance programs starts small, focus on the most critical assets, and combine technical rigor with operational buy-in. When those pieces come together, predictive maintenance becomes a game changer rather than just another digital initiative. This is what I believe.
That's well said, because it's not just a downtime problem, it's also an optimization problem. And the workforce should naturally feel that it's augmenting their skills and not just for the sake of implementing AI. And that is a very clear message coming to you as to the adoption. And also, I really impressed upon how do you count and account for the cost. So well said again. So these are very much, in resonance with what we hear as well as in the market. Slightly moving from the product manufacturing to how it is delivered. Manufacturing down the stream, beyond the factory floor. I also want to understand how AI is transforming the supply chains. What are the problems that manufacturers are solving here? Either to get raw materials in on time or ship the products in a very optimized manner. What problems are manufacturers solving here?
Awesome, and pursue. So when we talk about AI in supply chains, the biggest shift is that supply chains are moving from being reactive and efficiency driven to become predictive, resilient, and adaptive. And that change has accelerated significantly over the last few years. So one of the most visible area is, I'll say, demand forecasting and inventory optimization. Especially the scale of a supply chain works in today's world when there's big conglomerates, the big e-commerce vendors, the big manufacturers. The demand forecasting and inventory optimization, I'll say, is one of the most visible areas. Traditional forecasting relied heavily on historical data and periodic planning cycles, right? So AI allows manufacturers to continuously update forecasts by combining internal data with external signals such as market trends, seasonality, customer behavior, and even disruptions. This helps reduce excess inventory while still maintaining service levels, which directly impacts working capital and customer satisfaction. AI is making a strong impact in logistic and delivery optimization other than demand forecasting. From dynamic route planning to warehouse optimization and transportation scheduling, AI helps organizations respond in near real time to constraints like capacity change, delays, or demand spike. So the result is better asset utilization, lower transportation cost, and more reliable delivery performance. And I can recall one of the areas where I was doing with India Smart City. Just by optimizing this logistic and delivery optimization, we could reduce critical area is supplier collaboration, where AI can analyze supplier performance, quality trends, lead times, and external risk indicators to identify potential issues. This allows actors to proactively engage, diversify, securing when needed, and avoid disruptions. They escalate. So when you look at the overall impact, the benefits compound. Manufacturers see shorter lead times, improved on-time delivery, reduced tick and inventory, and greater supply. As importantly, planners and decision makers can spend less time firefighting and more time making informed strategic decisions. So in a sense, AI is helping supply chains evolve from a cost-focused function into a strategic capability that supports growth, resilience, and competitive advantage.
That's great to hear, particularly from not just the demand forecasting and inventory optimization, but literally with the kind of disruptions and the changes that are happening, how we go beyond our traditional functions to supplier collaboration and in making sure that there is not just delivery but also transparency along the way. That's good to know because we are in a new global order with global challenges as well.
Yes.
So I could almost resonate. Now shifting gears from an external perspective to the human workforce transformation, particularly around the manufacturing workforce. We have heard a lot about AI in the world of software development, IT, and so on. But the manufacturing workforce specifically who are based on skills and they are adopting technology, how should the manufacturers think about this transition, particularly from a workforce point of view? And the near perceived AI automates more tasks. The threat of that or the feeling of threat, how do you address it?
Awesome. And this is probably one of the most important question in any AI conversation. And I could have been surprised if this question could not have came. So in my experience, AI in manufacturing is much more about job transformation than job displacement. While certain repetitive or manual tasks will be automated, the overall demand for skilled people doesn't disappear, it shifts. Now, what we're seeing is a move from execution heavy roles to decision oriented and oversight roles. Operators become system supervisors, maintenance team become reliability engineers, and planners become scenario evaluators supported by AI. The work becomes less about reacting and more about anticipating. So this shift makes reskilling and upskilling absolutely critical. Recently, we were working with a couple of universities and some of the consortiums to try to see how human and AI workforce will evolve together. And we all and we are targeting many sectors like manufacturing, healthcare, and many other sectors. Manufacturers need to invest not just in technical skills like data literacy or AI basics, but also in problem solving, system thinking, and cross-functional collaborations. Importantly, learning has to be continuous and embedded into daily work, not treated as a one-time training event, which is ongoing still traditionally. So new roles are also emerging, such as AI product owners, data engineers for industrial systems, digital maintenance specialists, and cybersecurity focused operation roles. And these roles sit at the intersection of IT, OT, and business. So they are becoming essential in modern factories. Change management, again, here is often the decisive factor. People need to understand why AI is being introduced, how it helps them, and how their roles evolve. When employees are involved early and see AI as a tool that makes their work safe, more efficient, and more meaningful, adoption accelerates. And believe me, we are human brain. We have crossed many barriers. You can still recall people when first computer came in India. Few state governments told that no computer will come to my state. Again, I'm repeating, if employees are involved early and see AI as a tool, they will adopt. So ultimately, the manufacturers who succeeded with AI will be those who treat workforce transformation as a strategic priority, not a side effect of automation.
That's greatly put it. So the manufacturers who succeed are the ones who take the AI invasion from a displacement to a transformation, while involving people on the way. Wow. Good. So while we take on those challenges of the world, the workforce along with it, we naturally expose ourselves, particularly in the resilience as well as the security aspects. And as you very well know, one of the most overlooked aspects of AI in manufacturing is the security. As factories become more connected, they become more vulnerable too. So around this critical dimension, as we say, we don't feel the effect of accident unless we meet one. So it is always like, okay, it's a problem in the future, we will come and solve when it comes across, but it cannot be an afterthought, as you and me would agree. So in the light of that, not just the security dimension or being vulnerable, the cybersecurity landscape in manufacturing is also changing. In regards to this, our manufacturing facilities are increasingly targeted by cyber attacks. What are the biggest threats to the so-called connected factories, and how are manufacturers responding to them?
This is indeed a very, very good question. And you are absolutely right. Security is often overlooked, and yet it's becoming one of the most critical issues in modern manufacturing. And this is not only manufacturing. I'll say this is a social problem. Until my house is not robbed, police is burden. When my house is robbed, or when some event happened, then only I see importance of police. And that's driving this entire cybersecurity industry from day one. But now, when this new technology stakes are evolving, the security landscape has completely changed. This is for all the industries, including manufacturers. Factories become more connected and data-driven. Their attack surface expands significantly. So the most common threats we see today include ransomware attacks. You have examples. These attacks, especially ransomware, can bring your production to a complete halt. The data theft, particularly around IPs, intellectual properties, process know-how, and operational data. Then operational disruptions, another threat area where attackers target availability rather than data, knowing that downtime in manufacturing is extremely costly, as I was responding to another question. So in terms of attack vectors, connected factories present several entry points. Legacy industrial control systems that were never designed to be internet connected are now exposed through IT-OT integration. IoT devices and sensors, if not particularly secured, can become easy targets. We also see increasing risk through the supply chain, where third-party software, remote access tools, or maintenance connections create indirect vulnerabilities. The impact of real-world incidents can be severe. We have seen cases where production lines were shut down, as I was saying you during initial conversation, for days or weeks, shipments delayed, and new safety risks introduced. Beyond the immediate financial loss, these incidents erode customer trust and can have long-term reputational consequences. So when it comes to how manufacturers are responding, the picture is mixed. Many organizations still have a reactive security posture, treating cybersecurity as an IT problem rather than an operational risk. However, there is a growing shift towards more mature approaches in previous couple of years, such as zero trust principles or network segmentation, continuous monitoring, and tighter governance across IT and OT environments. Especially in previous 1 or 2 years, I'll say zero trust principles have emerged as a big player in this segment. Zero trust principle is saying that no one component can trust to other component unless it's policy bound. So what is becoming clear is that cybersecurity has to be designed into digital transformation from day one. AI and connectivity bring enormous value, but without security and resilience, they also introduce systemic risk. So the manufacturers who are ahead in the space treat cybersecurity not as a compliance exercise, but as a core enabler of safe, reliable, and scalable operations.
So moving beyond compliance and not thinking it as an afterthought is where the secret sauce lies. That's well said again. So now, having gone through your personal journey, what are all the use cases, and then how people journey on the way, let's take a step away and talk about all these culminates to India being one of the chief adopters of the technology, as well as global companies trying to set up their operations here and we becoming global players. So in the context of India's manufacturing AI opportunity, and you're based in India, which has a unique opportunity in manufacturing, let's explore India's potential and challenges it faces in AI adoption as a country. How do you assess the state of AI adoption in the Indian manufacturing compared to the global leaders? And where are we in this journey?
Awesome question, and really thought-provoking question. So if in my perspective, India's manufacturing AI journey is at an important inflection point. Compared to global leaders, we are still earlier in terms of large-scale enterprise-wide AI deployment. But the momentum and potential here are very strong. Surprisingly, we are the largest supplier of AI technology to the globe. But when it comes to integration, we are still, I consider, at a below of mid-stage, but in terms of adoption and maturity, most Indian manufacturers are in, I'll say, early to mid stages, focused on pilots, targeted use cases, and localized deployments rather than full-scale transformation. That said, this is changing quickly, especially among large enterprises and export-oriented manufacturers who compete globally and feel the pressure to digitize. When we look at sectors leading the way, automotive and auto components are clearly ahead, driven by strong automation, quality requirements, and global supply chain integration. As I told you earlier, that healthcare, pharmaceuticals, and life sciences progressing, particularly in quality, compliance, and process optimization. Electronics manufacturing and especially chemicals are emerging fast supported by government initiatives as well, and increasing investment. I'll say the investment has gone here almost 5 to 7x. The biggest opportunity for Indian manufacturers is that many are not burdened by deeply entrenched legacy systems, and this allows them to adopt modern digital platforms, cloud-based analytics, and AI more selectively and efficiently. So, combined with India's strong engineering and data talent pool, this creates the potential to leapfrog certain stage of maturity, especially when it compared to global players who are quite early in manufacturing segment and still deeply overburdened by their legacy systems, where integration is becoming a key challenge. So at the same time, there are other challenges that need to be addressed. Talent availability is quite uneven, especially when it comes to skills that bridge manufacturing domain knowledge with data science. Infrastructure is still a pain, particularly capturing reliable data at the shop floor level. This remains a hurdle for many mid-sized manufacturers. Capital constraints and ROI uncertainty can slow decision making, and awareness of what good, I'm saying by quote, good AI adoption really looks like is still evolving. So overall, I'd say India is moving from curiosity to intent stage. The next phase would be execution stage, building strong data foundations, developing talent, and scaling proven use case. And if that happens, Indian manufacturing has a real opportunity to compete and in some areas even lead on a global stage. And to add it, I can see a strong motivation from government, from industries to come together and move it forward. So I believe we have good chance to compete on a global stage if we go hand in hand, considering the challenges which I was mentioning.
So definitely there is no paucity of curiosity and adoption, but skill and talent has to be bridged, though it exists. Good to know. Now, I think we went from all the challenges and the use cases at the manufacturing level and implementation of AI in the manufacturing, as well as the country as a whole. Ramesh, Rakesh, thank you so much for sharing your insight with us. This has been incredibly valuable for anyone involved in manufacturing or technology. For our listeners, if you want to learn more about AI in manufacturing, check out industry resources and connect with thought leaders like Ramesh on LinkedIn. Thank you all for listening. We'll be back soon with more insights from industry experts. Thank you.
Thank you, Satya. I really appreciate the work you guys are doing by building this community around meaningful and practical discussions on AI in manufacturing. And I hope our exchange helps listeners think more clearly about how to approach this journey in their own organizations. So thanks again, and I look forward to stay connected. Thank you very much.